Yeah. So the first questioner there says, what is our cave exactly and why are we using it? And how best can we determine the best value of K? Well, the K is known as the hyperparameter. There are many parameters that we do encounter. See, for example, when we, let me open the Weka environment, I'll show you something. Here you can see, this is when I go to K nearest, this is K nearest neighbor. Sorry, this is classifier. This is K nearest neighbor. This is a parameter, batch size, cross-validate, number of decimal places. How many decimal places I want to be seeing my result. All these, they are parameters. However, this is not hyperparameter. Among these parameters, the hyperparameters, they are those that affect the algorithm directly. And that is K. K means K nearest neighbor. I will refer us to check out our YouTube and search for K nearest neighbor. We've explained it, how it works, the theoretical background, the theoretical backing of it. You can, it's very interesting, one of the very simple machine learning algorithm. It works on the principle of show me your friend, I will tell you the kind of person you are. So if you have 3 friends and we use K is equal to 3, if in three of your friends, 2 of them are good, 1 is not good, then KNN will say that you are a good guy. Because 2 of your friends out of 3 is good, majority. But if you have friend, we use K is equal to 5, we find out that 3 out of those 5 are not good guy, 2 only good. That means that person is not good in classification. The same thing also principle is used in the regression process. So that value of K is very important because once you change from 1, it may be the one that work for you. And as to how do we know the value that work? That is, if you follow the principle of let the data speak. Nobody can tell you exactly what value of K will work. K is got to 1 as worked for us before in some problem. Just 1. We try to change it to 3. Usually, people say optimum value are like 7, 9, 11, and 13. But we have problem where we got the best from K is got to 1. It means only one neighbor will determine the best result. In some cases, 3, 5, 7. See, so you have to put your data there, change it to K. It's got to, like I did today. I try 1, it was 92% correlation. When I try 3, it jumped to 98, and even the result became better. And I can try 5. At a point, the result will go down again. Then you go for that value of K that is the best. Then another hyperparameter in K nearest neighbor, there are 2 hyperparameters for K nearest neighbor. The second hyperparameter is the one we call the distance measure. The distance measure. You see, in the distance measure, you see here, you go to distance function. So we can have Euclidean distance is usually the default value. So the one we are doing now, we are using Euclidean distance. You are expected that you should check for shape. Once you have gotten the best value of K, then keep the best value of K and then start changing the distance measure. Leave the default is Euclidean. Look for Manhattan distance, Minkowski distance, Chebyshev distance. And if you become very interested in AI, you can, in machine learning, you can even develop your own distance measure when you know the way it works. It's an idea of, okay, how do we calculate the distance between 2 objects? So this is called hyperparameters. So the distance measure and the K, they are the 2 hyperparameters for K nearest neighbor. Whereas for some algorithm like support vector machine, there are several, maybe 5, 6, 7 hyperparameters. Then we have to optimize them. We have to tune them to make sure we get the best value before we conclude that it's not working, because some people will just use the default value and say, oh, we are sorry, this system is not working. No, we have to do hyperparameter optimization for it. And then it is then we can say that, okay, we have used two methods. And it's also good to have to try several algorithms. 1, 2, 3, 4. Decision tree, you can try decision tree, which is right here. You go to decision tree here, you see there, you see 3. This is 3. There are a group of 3 algorithms. Decision stop. So pick one of them, especially the simple one. And then how do I know the upper parameter? The upper parameters are usually mentioned in this place. You can see upper parameter is M is set to 4.0. So number then you move on it, and then you can run the system. Maybe decision tree will be better than K. It's always good to compare. In machine learning experiment, we compare because you never can tell. You can see now decision tree, the first attempt, we are getting 98%. 0.98, yeah, correlation. Even the mean square error, the absolute. So this is how we have to check several algorithms and then see which one works for us. So I hope that answered the question. So, and how best can we determine it? We use the principle of let the data speak. We've had several live sections. You can see, you can check out the video. The principle of letting the data speak. How to ensure you are building your model in the right way without too much pre-processing and without missing the insight that you are actually looking for. So I believe that is hopefully that what we'll be able to take today. And there's no other question. Thank you very much all for listening, and wishing you all the best. And before we call it quit for the day, so we are going to, as usual, we encourage us to try as much as possible to practice what we've learned, keep learning, and reach out when it becomes necessary for guidance, for further guidance, or as the case may be.